This curve represents a function, but the second curve does not represent a function. Why? Tell me why. Why this curve represents a function, but the second curve does not represent a function?
Because it crosses 2 points on the graph.
Right. Look at the vertical line test, right? Look at this picture here, see? Right? You draw a vertical line, it meets what? More than 1 point here, right? Actually, it meets 2 points here. Yes? So this function for x equal to a, you have 2 values associated with a, right? So this function is not defined. I mean, this curve does not define function, but this curve is fine, right? If you draw the vertical line, you will meet only 1 point here, right? So first curve represents a function, the second curve does not represent a function. Okay, so not every curve represents a function. Okay, now let me give you another example here. Okay, another example here. Now let's look at this graph. Okay, everybody should remember. Let's look at this graph. Tell me, does this curve represent a function or not?
No.
Yes or no? Why?
No, because it crosses. It doesn't pass the vertical line test.
What? Right, you draw the vertical line test. You draw the vertical line here. It meets more than 1 point, right? So this curve does not represent a function. How about this curve? Look at this curve. About this curve. About this curve. Yes. It fits what? The vertical line test, right? Fits the vertical line.
Yes.
Yes. How about this curve? Let me. Okay. How about this curve? How about this curve? Let me draw another picture. Okay, there's another picture here. A circle, a perfect circle. Yeah.
No.
See? Circle. Why this is not a function? Tell me why. Again, if fails what?
Crosses 2 points.
The vertical line test. Yeah, it meets more than 1 point here. All right. So this is a function. This is not function, and this is not. Right? Got to remember. Okay. Got to remember. Okay. Now let's. Okay. Now we understand, right? Vertical line test. Okay. Now look at this. This is what? The
inverse.
X equal to y squared minus 2, right? This is y equal to square root of x plus 2. This is y equal to negative square root. Okay, so what's the difference between them?
Sideways.
One is y equals and one is the other. One is x equals and the other two are y equals.
Yes. This is not a function of x, but this is a function of y. Y. Yes? See? If you draw the vertical line, you will meet more than 1 point, right? So this is not a function of x, but this is a function of y. Y. Yes? See? Right? It's a function of y. How about this? Is this a function of x? Look at the picture. Yes or no?
No.
Yes?
That's a...
Because it fits the vertical line test. How about this?
Yeah.
Is this a function of x?
Yes.
Same thing, right? If you draw the vertical line, you will meet the vertical line test, right? So this is not a function of x, but this is a function of y. This is a function of x, is also a function of y, right? This is also a function of x, is also a function of y. Yes? So this is the whole graph. This is what? The top half, this is what? The bottom half, right? See? This. The second graph is the top half for this graph, right? And the third graph is what? Is the bottom half for this graph, right? So this is not a function of x, but this is a function of x. This is also a function of x. Okay? Got to remember, right? It's easier to see from the picture, right? Okay, so we have finished. Okay, we have finished. Any questions so far?
on the
Any
graph
questions
part,
so far?
on the graph, it
I want
the
to,
letter
yes,
is that graph on letter A is a function?
yes,
I asking if that with that inverse on question A, is that a function? The inverse of y, I mean inverse of x.
yeah, okay, I answer the question. Sometimes you can find the inverse, sometimes you cannot find the inverse, right? Like y equal to x, like this, okay? He said sometimes you can find the inverse, but sometimes you may not find the inverse. Let me see, where is it? Yeah. Here. You can see it, right? Yes or no? Right? Sometimes you can find the inverse, but sometimes you may not find the inverse. Okay? I will go over that in a few minutes. Okay? Now, piecewise defined function. So what does it mean, piecewise defined function, right? So let's look at the definition here. Okay? Definition here. Okay, piecewise defined function. Okay. See?
So why do we call it a piecewise function? Well, because it's in pieces. Let's look at the piecewise function f of x equal to absolute value of x. This is defined to be x if x is greater than or equal to 0, and the opposite of x if x is less than 0. Notice we have two different functions, but they are only defined on certain values of x. Here we graph y equals x, the first piece of our range, only for positive x values, since our domain states x is greater than or equal to 0. And a graph y equals the opposite of x, the second piece of our range, only for negative x values, since our domain states x is less than 0.
All right. So this is called what function? Piecewise defined function. See? Okay. The function is called piecewise defined function. Okay. So for this function, fx equal to absolute x divided in how many pieces? 2 pieces, right? One piece is for what? For x is non-negative. And the second piece is for x what? Negative, right? So they are defined differently. For x is non-negative, the function value is x. For x is negative, the function value is negative x, right? So this is for absolute value x, right? It's called the piecewise defined function. It defined in 2 pieces. Okay? See another function here. See? This function is also called piecewise defined function. Why? It defined in how many pieces? 2 pieces, right? If x is less than or equal to -1, this function is y equal to 1 minus x. If x is larger than or equal to -1, the function value is x squared, right? So this function is piecewise defined because it's defined in 2 pieces. Okay, 2 pieces, right? One is 1 minus x on the left side, right? The other is on the to the right of -1 is x squared, right? X squared. So let's look at how to sketch it. Okay, sketch it. You want to know how to sketch that, right? See, this is a picture. See, this is a picture. See, right? For x, look at the graph. That's the function, right? Fx equal to 1 minus x, and this is x equal to x squared. Okay, so let me. Okay, so let me write down. Okay, this is fx, right? Equal to tell me what's that? What's the first piece?
-1.
Remember? What's the first piece?
X minus
Remember? Just
1 minus negative x.
1 minus
minus
x.
x.
Yes or no?
It's 1 minus x.
Yes, 1 minus x, right? Minus x. Right. For what? Tell me, what's the domain for this piece? What domain for the first piece? X is what? Tell me, what's the domain? Don't
Less
be
than
shy.
Is x
Let's say
is
what?
Smaller than or equal to -1.
Yes, -1. So -1 is the what? Is the very important point. How about the second piece? Is x what?
X squared.
Square, right? X is what?
Greater than -1.
Right? So this is, yes, x is larger than -1. Now, let's evaluate f at -1. What's the value for f? Tell me, what's the value for f? If f equal to -1, you have to use first piece or you have to use second piece to find the value for at -1 for f.
First piece.
first piece?
You have to make a choice. Why first piece?
What?
Why you have to use
Because
first piece to calculate f -1?
Because it says if
Because
x is equal
Why
is
so?
less than or equal to.
Right. Because x is less or equal to, right? The function is defined at -1 for the first piece. So put a -1 inside. What's the value for f -1? What's the 1 minus -1?
2.
2, right? See, at the function is -1, the value is 2, right?
1 minus
If we use the second piece, f -1 will be 1, right? So you have to use what? A small circle, you see? It's a small circle, right? What? F -1, you put a -1 in the first piece, not in the second piece, right? The second piece is not defined for x equal to -1. So what's the 1 minus -1? Is 2, right? So the value for at x equal to -1, the value is what? 2. If we use second piece, the function value will be 1, right? But 1 is not defined here, right? So you have to use what? A small circle. See small circle here? This is what? A solid dot, right? This is a small circle. See? Right? A small circle. See? Right? Because the function value at the -1 is not equal to 1, but equal to what? 2, right? 2. Now, please find, everybody please find f0. What's the value at f0? Please find it.
0.
0.
What's f0
Zero.
here? Why 0? Why?
Because
Why
0
so?
squared is
0 to the square is 0.
Yeah, because 0 is what? Larger than what? -1, right? So 0 is in the domain for the second piece, right? So f0 will be 0. Good. Everybody understand, okay? How about f at 1? What's the answer?
1.
Why 1?
1.
Can you use first piece or use second piece to find f1?
Second piece.
Second, because 1 is greater than -1.
Right. So what's the 1 square?
1.
Right? Yeah. See? The function, look at the picture, right? f0 is 0 and f1 is 1, right? So this is the first piece. This is what? The second piece. Right? So this is the first piece, right? This is the first piece, right? This, the picture is for this. Right? This picture is for second piece, right? Okay, you got to remember, they are not same, right? And you half line, right? This is called what? The parabola, remember, right? Part of the parabola, right? X squared, right? Okay, so this is called piecewise defined function. Okay, piecewise defined function. You have 2 pieces, right? You have 2 pieces. Okay. So we're done with these, right? Everybody should learn how to sketch a piecewise defined function. Okay. not hard at all, right? Not hard at all. So we have finished it. Okay, have finished it. Okay. Now this is absolute value, but that's easy. Okay. Now this important. Okay. You have for absolute value of a, if a is larger than or equal to 0, that's a, otherwise equal to negative a, right? Remember, negative a is not always negative. Okay, so please write down. Okay, so I want you to understand. Okay, negative a, please write down. Okay, negative a is what? Is not always what? It's hard to write. Okay, it's not always. Okay,
It's not always negative.
not always a negative number. Right, it's not always a negative number. Okay, a negative number. It's very important for you to understand. Okay, a negative number. I don't know how to write. Right, so please write down. Okay, negative number. N-U-M-B-E-R. Okay, so negative a is not always a negative number. Why? Look at these. Negative a. Okay, if a equal to negative 6, what's the value for negative a? Tell me, what's the value for
6.
negative a if a equal to
Positive 6.
huh?
6.
Positive
Positive
6.
6. See, right? So yes, so this in this case, negative a will be equal to negative 6, right? So it will be positive 6 here. Right? So negative a is not always a negative number. You got to remember, okay? Each class, oh, you have negative a must be a negative number. That's wrong. If a is negative, then negative will become what? Positive. Right? So it's a common mistake to think that negative a is always a negative number, but that's wrong in mathematics, right? Because it depends on what? On a. If a is a positive number, then negative a will be a negative number. If a is a negative number, then negative a will be a positive number, right? So it's wrong to think that negative a is always negative. It's always a negative number, right? That's wrong, okay? That's wrong. Got to remember, this is very important in mathematics. A lot of people make mistakes, think negative a is always negative, but that's wrong, right? Negative a can be positive, a is negative itself, right? So you got to remember, this is very important for you to understand, okay? For you to understand, okay? So we have finished. See, remember that if a is negative, then negative a is what? Is positive. See, this is very important for you to remember, okay? So please write down, okay? If a is negative, then negative a is positive. Okay, this is an important concept in mathematics. All right? Okay. Otherwise, you will make a lot of mistakes to think that negative a is always a negative number, because that's wrong, right? That's wrong. Now that's easy, right? We have learned how to sketch absolute value function, right? This is a picture. Remember the video, right? Remember the video, the guy just sketched these functions, right? So I don't want to repeat, okay? Because this is so straightforward, right? So straightforward. Okay, so this is look at this function. Look at this function. How many pieces here for fx? Look at this function. Fx here. Yes, in how many pieces? 3 pieces, right? The first piece, the second piece, and this is the third piece. Okay, so you can have a function with like 4 pieces, 5 pieces, so on and so forth, right? So we have finished this part. Okay. We have finished this part. So we learned how to find so-called piecewise defined function, right? Okay. Now symmetry is also easy, right? Now look at this function. Look at this, the graph for this function. This is what? Symmetry will respect to what? With respect to the y-axis, right? Because you can use the y-axis as a mirror. The left part and the right part are mirror images to each other, right? So this is called what function? Even function. Okay, so even function is always a function an even function is always a function with what? With
Symmetry
the
of the
graph
y-axis.
symmetric with respect to the y-axis. Okay, so you can regard the y-axis as a mirror and the left part and the right part are mirror images to each other. Okay, now let's look at another picture. Look at this picture. This is called what function? Odd function, right? So odd function, the graph is symmetrical with respect to what? To the origin here. Okay, so we have two types. One is even function, and the other is odd function. Okay, so remember the graphs. Even function, the graph is symmetric with respect to the y-axis. And for the odd function, the graph is symmetric with respect to what? The origin. Okay, so let's look at the video here.
Now let's look at two special types of functions, even and odd functions. First, an even function is a function where f of the opposite of x is equal to f of x for every number x in its domain. What's special about this function is that it's symmetric about the y-axis. This means when we plot the graph of f for x greater than or equal to 0, we obtain the entire graph simply by reflecting this portion about the y-axis. For example, f of x equals x squared is an even function, because if we plug in negative x for x, then f of negative x is equal to negative x all squared, which is equal to negative 1 squared times x squared, which is equal to x squared, which is equal to f of x. And its graph looks like this. Notice we reflect the right side of the graph with the left about the y-axis. An odd function is a function where f of negative x is equal to the opposite of f of x for every number x in its domain. Now, an odd function is symmetric about the origin. This means that if we plotted the graph of f for x greater than or equal to 0, then we obtain an entire graph by rotating this portion 180 degrees about the origin. For example, f of x equal x cubed is an odd function because f of the opposite of x is equal to the opposite of x all cubed, which is equal to negative 1 cubed times x cubed, which is equal to negative x cubed, which is equal to the opposite of f of x. And its graph looks like this. Notice that you can rotate the right side of the graph 180 degrees to get the rest of the graph.
Okay, right? This is, so we have two types of function. One is even function, and the other is what? Odd function. Okay, so remember, even function is, so let me. So this is even function, okay? F negative x is equal to fx, right? So that's even function, okay? This is even function, even, okay? Even function, right? If you have f negative x is equal to negative fx, right? Then this function is what? Called what function? Odd function. Okay, odd function. Okay, so you have two types, right? Even function and odd function. Okay, even function and odd function. Now let's look at this. A. Fx is x fifth plus x. Is an even function or odd function? Tell me.
Is it even?
Odd.
No, x fifth plus x. The even function or odd function?
An odd function.
You have to use definition, right? You have to replace what? X by negative x to see what happens, right? So replace x by negative x. So you have negative x to the power fifth plus negative x. So this will be negative x fifth. This will be negative x. So negative is, you can put outside, right? So this is x fixed plus x, which will be negative fx. So what's function mean? The function is what? Order function. Because f negative x is equal to negative fx, right? Now let's look at another function. Gx is 1 minus x to the power 4. Let's take a look at the function is even function or order function.
Neither.
Even function. Why? You replace x by negative x for g, right? It's 1 minus negative x to the power 4. Now negative to the power 4 is positive, right? Positive 1. We have these equal to gx. Right? So g is even function. But not every function is always even or always odd, right? Let's look at hx. hx is 2x minus x squared. Let's look at this function. Okay, hx is 2x minus x squared. Now, please do it by yourself. Don't look at the notes here. Let's find out by yourself to determine if hx is even function, odd function, or neither. Okay, do it now. Find out by yourself. Okay, do it now. hx is 2x minus x squared. 2 times x minus x squared. Please do it by yourself to determine if it's an even function, odd function, or neither. Do it. Everybody, spend 1 minute or two. Don't waste your time, okay? You got to be what? You got to be active, right, in learning mathematics. You cannot just wait and even function or odd function, tell me. hx equals 2x minus x squared. You have what? Even function, odd function, sometimes it can be what? Neither even nor what? Odd, right? So you have one more possibility there, right? For the function 2x minus x squared, even what? What's the answer?
I got neither.
Neither. Good. The right answer is what? Say again. William, say again.
I
What's
say
the
I
answer?
got neither. I got neither.
Neither. So the right answer is what? Neither. Okay? The right answer is, you are right. The right answer is neither even nor what? Odd. Okay? This is the right answer. Okay? Now let's take a look at here. Okay? I want to. Here. Okay? Let's look at the answer here, okay? Let's look at the answer here. See? hx is 2x minus x squared for the negative x inside, right? So 2 times negative x minus negative x squared become what? Negative 2x minus x squared, see? Right? Negative 2x minus x squared. So this is h negative x is not equal to hx, and h negative x is not equal to negative hx, right? So we conclude that it is neither even nor what?
Symmetry.
Nor odd.
Function f satisfies.
Don't worry about that. Okay. So the function is neither even nor odd. Okay. So sometimes the function can be neither even nor odd. Don't forget that. Okay. Don't forget that. Okay. Now let's look at the picture here. Look at first one. A, even function or odd function. Look at the picture. You can look at picture to determine the even function or odd function. For the A, even function or odd function. Odd. For the B, even function or odd function.
Even.
B. Yeah.
Neither.
Even. For the C,
Neither.
even function or odd function. Or neither.
Neither.
Neither. Right? Neither. This is neither. Right? Neither. Okay? Neither. So we have done. Okay? Easy to see from the picture. Right? From the picture. Now look at this. This is what? Let me see. This is increasing or decreasing function, right? Now look at this. This part is increasing. This part is what? Decreasing, and this part is what? Increasing, right? Okay. Now let's look at this. Look at the graph here. Tell me, this is on which interval this is decreasing, on which interval this is increasing? Tell me. This is
Decreases
what?
from negative infinity to 0.
Decreasing, this is what? Right. This is that, okay? This is that. Okay? This is very easy to understand, right? Very easy to understand. So you have even function, odd function, and increasing and decreasing function. Now let's look at these. This is just exercises, right? So we have finished section 1.1, okay? So this is just exercises. Now what's 1.2? 1.2 is 1.2 here. Let me get 1.2 is mathematical models, a category or a catalog of essential functions. Okay, so let's take a look at. This is just models. Okay, a lot of words here, right? Now I want you to see this is linear models, a linear function. This is linear function. See, linear function is this. Okay, y equal to fx equal to mx plus b. This is one of the most important functions in mathematics, right? It's called linear function. So if you draw the linear function, the graph will be a what? Will be line, will be a straight line, right? Will be a straight line. Okay, this is linear function. Linear function is very easy to sketch, right? See, right? Linear function. So I don't want to spend too much time on this part, right? No, this is a linear function. 3x minus 2, right? 3x minus 2. Now, what's the slope here? What's the slope for this? In what?
3.
The slope. Look at the picture. You got to remember what's slope here? If y equals to 3x minus 2, what's the slope for this line? Look at the function.
3.
3. What's the negative 2? Negative 2 is called what? Y-intercept, right? So y-intercept is negative 2. The slope is what? 3, right? See? The slope is 3. The y-intercept is negative 2. Okay? This is so-called linear function, right? You can sketch this. In order to sketch a line, how many points do we need to sketch a line? Tell me, how many points do we need?
2.
To sketch a line, huh? 2 points. 2 points will suffice, right? You find 2 points and you connect them and then extend it, right? It becomes a straight line. So in order to sketch a line, all you need is 2 points, right? You can sketch. Very easy to sketch a line, right? So this is called, now this is another linear function. This linear function is what? Increasing or decreasing?
Decreasing.
Decreasing, right? When x go, when value x goes to the right side, the y value will be down. Now this function is what? Increasing, right? When x goes to the right side, the y value goes up, right? So a linear function can be increasing or decreasing depending on slope. If the slope is positive, increasing. If the slope is negative, it's what? Decreasing. If the slope is 0, it becomes constant, right? Okay, this is so-called linear function. Okay, so linear function is very easy to handle, right? So we learned this linear function. Okay, now next is called what? Polynomials, right? Polynomials. Okay, polynomials is this. See, this is polynomials. Okay, this polynomial is defined by an x to the power n, so on and so forth, and a1x plus a0. So you have a bunch of power functions, you add them, right? See, look at this. This is a polynomial. What's the highest power here? 6, right? 6. This is 6. This is the fourth. This is the cubic power. This is just a constant term, right? So this is a polynomial of degree what? 6, right? Degree 6. Degree means the highest power, right? Highest power is 6. Okay. Now, of course, polynomial, this is a special case of polynomial, right? For the linear function, the degree is what? Is 1, right? So linear function is a special case of a polynomial, right? With degree 1, okay? Now, this is the graph of what? Quadratic polynomial, right? See, this is the graph of x squared plus x plus 1. This is the polynomial of degree what? 2, right? Degree 2, the highest power 2, right? This is negative 2x squared plus 3x plus 1. This is what? This is another quadratic polynomial, right? This is opens up. This polynomial is opens what? Opens down, right? So for a quadratic polynomial, the graph can open up. For this, the graph opens down, depending on what? On the number of the highest power, right? If the highest power here is positive, the graph is open up, right? If this number is negative, the graph opens down, right? Concave up or concave down, right? Now this is what? A cubic polynomial, right? Cubic polynomial. Now this is a sketch for a cubic polynomial, right? The graph is more complicated, right? More complicated. Now this is the graph for this. This is the degree 4 polynomial. This is degree 5 polynomial, right? So if the degree is higher, the function becomes more complicated, right? But the idea is similar, okay? Idea is similar. So this is the polynomial function, okay? Polynomial. Now power function is like this, okay? X to the power n, right? It's so called a. Sorry, a is a constant. It's called a power function. Okay, power function you have to remember is x to the power a. A is a constant. Sometimes a can be 0. Sometimes a can be positive number. Sometimes a can be what? Negative number, right? So we are out of time. Okay. Now, please ask if you have any questions. Don't be shy. Please ask. If you have any questions, please let me know right now. Don't wait until next week.
Are we able to start on the homework assignments now, or should we wait on that?
I'm sorry, what? What's your
Are we able to start on the, are we able to start on the homework assignments now?
Yeah, you can start now. Homework for at least you can do section 1.1 and 1.2, I think. Okay, so we have finished 1.1 and we almost finished 1.2. Okay, so at least you can do these 2 sections because they are not new. Everything is old, right? We have learned this in Math 1125 and 1126. Remember, right? This is nothing new. Okay. Chapter 1 is just basically what? A review of all the stuff.
Well, it's been a while for me since.
Nothing new here.
It's been a while since I took a math class. I took math 1021 and 1022 back in my junior year of high school. I tried calculus in my senior year, but it was too much at the time. Yeah, I think all I needed was a break. And I remember a lot of this stuff that you showed us today. So that's good.
Good. Chapter 1 just help you to refresh your memory, right? Because you have learned the math 1125, 1126, possibly last semester or 1 year ago, right? Possibly you may have forgotten some stuff, right? So chapter 1 basically help you to review, right? Review the all the stuff, okay? So chapter 1 does not contain anything new here, right? Just help you to refresh your memory, right?
Yep.
And fix some terminology here, right? Like even function, odd function, increasing, decreasing function, domain, range, so on and so forth, right? Because chapter 1 does not contain anything new here. Just any question. So what's the time for our next meeting? Remember? Not tomorrow, right? Tomorrow we don't have class. What's the
Monday,
meeting for
6:30.
next class?
Monday at 6:30.
6:30.
Monday, 6:30, right? Any questions so far? You can ask, okay? I'm available for you anytime. It's these.
Dr. Yao, I had a question about the
Yes,
piecewise functions. Are they limited to 2,
yes.
or they will be like? Can you
No.
do like 3, 4, 5 functions in a piecewise
No, you can
function?
have more than 2 pieces. No, you can have more than 2 pieces, not limited to.
Okay.
Yes. How many pieces can you have? A lot, right? A lot. You can have what? 2 pieces. You can have what? 3. You can have what? 4 pieces. You can have 5 pieces. As many as you want. So not only limited to 2. Okay.
Thank
Yes
you.
or no? Remember, right? Any more questions? You can ask. Okay, don't waste your time, right? Because otherwise you have to wait until next Monday, right? If you don't, you can leave. But if you have questions, you can stay. Okay, I want to help you to understand math. Okay.